Good morning. Am I audible to you?
Good morning, sir.
My voice is audible to you?
Yes, it is audible.
Right. So only 8 participants are joined here. We will start today's session in a couple of minutes. So all of you good with whatever the concepts we discussed as of now with respect to course? Sorry.
Yes, sir.
So everything is good as of now?
So actually, due to certain circumstances, I was unable to attend few weeks classes, so I will have to cover them up, sir.
Okay. Vincent, as of now it is good? As of now it is good. Are there any doubts, Vincent? Okay. Okay, right. So last class we completed about different types of switching techniques and delays. So I request all the students, how many types of switching techniques we discussed? You can post in chat box. How many types? How many types? Yeah, 3 types. Okay. So even though I'm showing 6 or 7, it is 3 types only. First one is circuit switching, and second one is packet switching, and third one is message switching. Again, packet switching is dividing into 2 parts: datagram switching and virtual circuit switching. Among these multiple switching techniques, which switching technique we use in physical layer? I'm expecting responses from you guys. If you need good faculty, I need good students. Are you good or not? Perfect. Excellent. What is your name, dear? Chandana. Very good, Chandana. I appreciate that. And what type of switching technique we are using and data link layer? Data link layer. Come on. Why we are wasting our time? What type of switching technique we are using in data link layer? First tell me, my voice is audible to you. Is it clear?
Yes, sir.
Yes, ma'am. Yes, sorry. Is it clear?
Yes, it's clear.
Okay. Then what about the answer? I'm testing whether you are following my classes or not. Your packet, the name itself packet. Yes, of course, packet switching again dividing into 2 parts: datagram switching and virtual circuit switching. Among these 2 things, which circuit technique, which switching technique we use in data link layer, and which switching technique we use in network layer? Because the data representation is not same in all the layers. Data representation, Ethernet switching, no, as of now we discussed about that point. Virtual circuit, Ethernet is nothing but virtual circuit. Yeah, excellent, virtual circuit network. And packet switch, inside the packet switch, we use datagram switching networks, It is used in network layer. That is something about, okay, anyways. So as of now, we completed all the switching techniques. I assigned 3 to 4 assignments, theoretical topics, direct general topics at Moodle box. So I observed that many of you students are not following properly, are not attending, are not submitting the assignments. See, whatever the marks you are getting here, I update the same marks in the final examination also. There is no requisitions, only hard work pays off. Whatever the things you are projecting, whatever things you are doing, those only will get the marks. We are copying, we are checking plagiarism also. Do your own job. If you do mistake, do it by own. I don't mind. I'll consider. If it is a mistake, I will consider, but don't copy. Don't cheat yourself. Right. So today we will discuss about different types of delays when we try to send a particular data or a packet or a frame from one host or one device to other host or other device, right? So what are those different types of delays? And we try to solve some gate questions and competitive exam questions in this session. My screen is visible to you?
Yes, sir.
Right. So today topic is delays in computer network, delays. For example, if you take device A and device B, it is one computer and it is another computer. Now, the question is, computer A contains a packet of data, whatever the things we have seen in the Wireshark packets, data transmission packet size, some payload of 512, 612, many things are there. For example, in this instance, my packet is this one, 1011.011 and 1. And here we are using a transmission medium. The question is, how much time, how much delay, or how much time it will take for device A to place this entire set of bits or packet into the medium. What is the time? And once device A place all this packet into the medium, how much time it will take to transmit this packet from this end to A one end to B one end? How much time? Anyways, after some time, this packet is successfully reached to this particular place at the other end. How much time it will take? To process by B? What is that time? Yes, please, Vincent. Any doubts? You raise your hand. Vincent, by mistake it was happened or intention you raise your hand? If so, please ask the question. He is not responding. My voice is audible to you?
Yes, sir.
Is it clear?
Yes, sir.
Yes.
For example, if B is busy with processing some other packets of device C, at that time it is not possible to handle this particular packet. So how much time it need to wait to take up by B? What is that time? If B is free, then how much time to process this entire packet by B? Process, what is that time? Process means checking header or checking content, whether the data is correct or not, for applying some error correction detection methods, check some everything. So here, what is this? And what is this? And what is this? And what is this? These are called delays. Sometimes we generally call it as nodal delay in general, but we are dividing into individual delays here, and we try to solve some of the problems on that one. As of now, it is clear. As of now, it is clear.
Yes, sir.
Yeah. So, for example, if you consider two devices that are connected to a transmission link or media, that may be coaxial cable or twisted pair or optical fibers or connectionless, anything, a data packet is sent by the host A to host B, following different types of delays occur during transmission. That is transmission delay, propagation delay, queuing delay, and processing delay. Let us see the individual definitions of transmission, propagation, queuing, and processing delays, and how those delays depend upon which parameters, what parameters we need to consider, all those things. First thing is transmission delay. So what is the transmission delay? The time required to transmit a packet from the host to the transmission medium. Here I am showing the graphical representation. See here. If a device is ready with the packet, maybe this packet is 1011011. How much time it will take to place this packet from device to the starting of the device to the starting of the transmission medium? That time is called transmission delay. Do you understand this? Do you understand this?
Yes, sir.
Yes.
Okay, if you really understood this concept, transmission delay is depend upon what parameters? Transmission delay is depend upon what type of parameters? Yes, please. Any smart answers? Okay.
The host itself.
Okay. Case 1, length of packet is maybe 1000 bits. Case 2, length of the packet is 100 bits. Among these two cases, transmission delay is more, in which case transmission delay is less, in which case?
It is more in case 1, less in case 2.
Yeah, in case 1, the length is more. That's why, because what is our definition? The time taken to place this entire set of bits into this link is called transmission delay. If the packet size increases, automatically it will take more time to place into transmission link. So according to this scenario, if the length of the packet is more, transmission delay is more. If the length of the packet is less, transmission delay is less. Do you agree with me or not?
Yes, sir.
Can I say that transmission delay is directly proportional to length of the packet?
Yes.
If length is increases, automatically delay is increases. Yes or no?
Yes.
Yeah. Yes or no? I'm expecting answers. Please be interactive.
Yes, sir.
Right. Again, I'm taking another case, case 1 and case 2. For example, the capacity of this link is, it can handle 1000 bps. It can at a time take 1000 bps. It can process, it can handle 1000 bps bits per second. It can transmit, it can handle that bandwidth, the capacity or bandwidth. It can process 1000 bits per second at a time. Bits per second means per second it can process 1000 bits. And case 2, the bandwidth, it can handle only 100 bps. So in these two cases, transmission delay, how can it relate? Transmission delay is more, in which case? Transmission delay is less, in which case?
Sir, more in case 2.
More in
Case 2, sir.
case 2. That means if bandwidth is less, transmission delay is more. Can I say this one? Transmission delay is inversely proportional to bandwidth.
Yes, sir.
Yes, sir. So if I comparing these two formulas, transmission delay is equal to length of the packet by capacity of the channel or bandwidth of the channel. Do you agree with me?
Yes, sir.
Right. That is the formula here. See, transmission delay, length or size of the data packet, transmission delay is inversely proportional to bandwidth. If bandwidth is more, it can take up more packets at a time, more bits at a time. If bandwidth is less, it does. So final formula for transmission delay, according to our discussion, is length of the packet by the capacity of the channel. In general, capacity will calculate in bandwidth. The parameter is bandwidth. Do you understand this? Or any doubts?
Understood.
Okay, if you understood this, please answer this question.
So,
If bandwidth Yes,
won't
please.
there be any constant of, since we are taking it from proportionality, won't there be any constant?
Yeah, constant means from here, for example, this particular link is optical fiber. Of course, optical fiber supports light. The light speed is always constant. That is 3 into 10 power 8. It is constant only. For explanation
Okay, sir.
purpose only, I am taking these points. You understand that?
Yes, sir.
Right. So what is the answer for this question? If bandwidth is 1 Mbps, that is the capacity is, it can process 1 bit per second. Every second, 1 bit can be transmitted onto the transmission medium. That means host can place only 1 bit per 1 second. If so, if the data size is 20 bits, then what is the transmission delay?
20 seconds.
Yes, of course, 20 seconds. Excellent, excellent. For example, if the data size is 2 KB, what is the transmission delay?
2000 seconds.
How much?
2000 seconds.
2000 seconds. No. How can we measure binary data? Either powers of 10 or powers of 2. Yeah,
Hours of 2, sir.
powers of 2. What is 2 power 10?
1024.
Yeah, right. So many students are doing the same mistake. In competitive exams, they specifically to confuse you, they mention 2K. Everyone go for this answer, but no. It is 2 into 1024 bits. Bandwidth, powers of 10, but data, not powers of 10. It's powers of 2. Hope you understand this answer. Right?
Yes, sir.
Good. So, of course, your answer is correct. It's good. So, as of now, we discussed the same thing. And what parameters depend upon the delay? Of course, length of the packet and bandwidth of the packet is a theoretical aspect. You can read it later. And second type is propagation delay. Propagation delay means, anyways, after the packet is successfully transmitted to the transmission medium, just place into the link, it must go through the medium to reach the destination as like this. We are successfully placing here. This is called transmission delay. But how much time it will take to transmit from the entire packet? Entire packet means including last bit. How much time it will take to reach the packet from this side to this side completely? This time is called propagation delay. Do you understand this? This time is called propagation delay. Do you understand this?
Yes.
Packet is transmitted to the transmission medium. It must go through the medium to reach the destination. Hence, the time taken by the last bit of the packet to reach the destination is called propagation delay. Do you understood this?
Yes, sir.
Yes.
For example, if data is 10011, it is transmitted here. So, transmit propagation delay is not meant about how much time it will take for first bit. It doesn't care about LSB, least significant bit. How much time to reach the last bit, MSB. Last bit means complete packet. That is called propagation delay. Now, what are the factors that affects propagation delay? Any answer? What are the factors that affect propagation delay? I'll tell you.
Sir,
one thing.
again
Yes, please.
the length of the packet.
Length of the packet. Okay. Okay, I'll take two scenarios here. If the length of the channel is 100 kilometers, the length of the channel is 1 kilometer. So propagation delay is more in which case, is less in which case.
More
More
in
in
first.
case.
Or in first case.
More in first case and less in second case. Can I say that propagation delay directly proportional to length of link, length of the transmission medium or distance? Can I say that?
Yes, sir.
And second case, if here this is optical fiber, case 1, if it is a coaxial cable, case 2. So propagation delay is more in which case, less in which case. Optical fiber means the data transmitted in the form of light, it is equal to light speed. Coaxial cable, it definitely less than light speed. So here speed is more, here speed is less, or velocity is more, velocity is less. If velocity is more, propagation delay increases or decreases?
Decreases.
Decreases. Because if a bike is traveled with 100 kilometers per second, you reach to university within 10 minutes. If you go by cycle, maybe it is 10 kilometers per second only, you can reach late. It exactly not 10 minutes, more than 10 minutes. So can I say that propagation delay inversely proportional to velocity of the channel? Yes, sir. Yes, sir.
Yes,
Yes.
sir.
Yes. And one of students said that length of the packet, of course, we need to consider this, but compared to this longer distances and longer velocities, it is almost equal to 0. Because if length is more, if you take 1 minute of time to reach the packet, maybe it is 0.001 second. We need to consider this, but it is almost equal to 0. That's why we doesn't consider length of the packet. This delay will calculate it transmission delay. Transmission delay. We consider as a transmission delay. It is also a delay, but it is not related to propagation. It is related to transmission delay. So from this one, I can extract that propagation delay is equal to length of the channel by velocity of the transmission medium, or in simple, distance by velocity. Are you agree with this point? Are you with me?
Yes, sir.
Right. Let us see whether this formula is correct or not. See, factors affecting propagation delay: distance. It takes more time to reach the destination if the distance of the medium is longer. Velocity of the signal is higher, the packet will be received faster. Right? If signal is optical fiber, light signal, of course, it is more fast. See, in this way, we can mathematically prove that distance by velocity. Here, velocity is constant for transmission mediums. If it is optical fiber, it is constant. Right. And what is queuing delay? Queuing delay means the time required. For example, here we take device A and device B. Device B and device A has a capability to send packet 1, packet 2, packet 3, and packet 4. So at a time, within second, device A can send 4 packets. 4 packets. But at a time, device B can handle only 2 packets. 2 packets. Right? In this context, is it possible to handle all the 4 packets at a time by the device B?
No, sir.
No, sir.
No. So when packet 1, packet 2, packet 3, and packet 4 transmit at a time, B immediately accessing P1, P2, but I don't want to lose P3, P4. That's why I create a queue here. A queue. In this queue, I can place P3 and P4, right? So how much time it will take to execute, to process packet P3 is called queuing delay. of P3. How much time it will take to process P4 by B, that is called queuing delay of P4. Do you understood this?
Yes, sir.
And if you consider P1, P2, it is already taken up by B. That means the processor of B starting executing P1, the time needed to complete the processing of packet P1 is called processing delay of P1. The time required to complete the processing of P2, that is called propagation delay of P2. In this way, we can define queuing delay and processing delay. Do you understand the difference? Do you understood this? Do you understood this?
Yes, sir.
Yes, sir.
Now, what are the factors that affects queuing delay and processing delay? For example, my processor is, I'll explain clearly. I take two cases, case 1 and case 2. Case 1, I'm using processor i7. Case 2, I'm using processor i3. Then processing delay is more in which case? Less in which case?
More in I3.
More in I3, sir.
Both? More in?
I3, sir.
Because it is less capacity as compared to i7. So can I say that processing delay is directly proportional, inversely proportional to processor capacity? Yes, sir. Processing speed. Yeah, right, of course. And what about queuing delay? Same scenario. Queuing delay. In which processor can wait more time to process the packets, pending packets, waiting packets, i7 or i3?
I7, sir.
Yes, sir. Queuing delay is also directly proportional to process time or speed. Because i7 process immediately, when it is executing existing packets very fast, those packets complete very fast. Once it is completed fastly, then it take up the next packets also. So either processing delay or queuing delay depends on destination device configuration, complete destination device configuration, right? So it doesn't have a direct formula because device to device, these processings are changes. And I request all the students, whatever the explanation I did as of now, read these points carefully. If the packet is received by the destination, the packet will not be processed by the destination immediately. It must wait in queue in something called buffer or temporary memory allocation. So the amount of time it waits in queue before being processed is called queuing delay. In general, we can't calculate queuing delay because we don't have any formula for that one. Why? Because processor. What is processor? Why it is not calculated means in this particular scenario, maybe I'm having, see here, all these are processor. All these are processors. If you did get power usage and GPU, how much, what is the network capacity, what is the disk, CPU, memory. So a system handling some thousands of jobs, a processor can handling multiple tasks related to your system that may be in network device combinations or non-network device, maybe a system connected to printer, one server, one device, maybe a system connected to server, maybe a system executing some backend Java program or .NET program, or many combinations are there. If all these services are, if a system doesn't handle any services, then processor is ideal and it can handle all the packets at a time. It doesn't even for queue also. But when the size of the non-dependent or non-network processors tasks are increases, at that time processor becomes very busy. At that time, it is not possible to handle the coming packets. So is it possible to decide, is it possible to calculate delay for each and every program, each and every task in real time?
No, sir.
No, see, almost in front of you, how many processors here? Almost 150, 200 processors. If I'm initiating any new task, so it is impossible or impractical for that I want to open Chrome, and Chrome contains 4 tabs. How much time it will take in, how much memory it will take in. So as of now, I'm not using any Chrome. That's why it is 0%. But if I'm opening Chrome, automatically see here it is 0.1%. Again 0, again 0.1, again 0. So within fraction of milliseconds and microseconds, these values are changing continuously. So it is not possible to capture all this data to estimate the delay. That's why it doesn't have any formula. Do you understand this?
Yes, sir.
Right. Okay. So these are the possible problems. So in general, we can't calculate queuing delay because we don't have any formula for that. Because if the size of the queue is large, the queuing delay will be huge. If the queue is empty, there will be lesser delay. So if more packets are arriving in a short or no interval of time, queuing delay will be large. Because if destination not capable to handle those many packets, then automatically all those things are not taken up by the processor. That processor may be busy with your internal services, your internal printer services or scanner services, or executing individual programs or maintaining databases. Then it doesn't handle incoming packets. There, all those packets are existing in the queuing delay only. Up to the completion of the priority job, then it go to the next. All these things are explained in operating systems. I believe that this semester we have operating system, right?
Yes, sir.
Yes.
You know, processing algorithms, first come first serve, round robin, shortest job first. Or if faculty explain all these things.
No, sir.
Okay, all these things are called processing algorithms, processing scheduling algorithms. There you understand all these points. Those people who only take care about system only, inside the system. But our computer network concept is in between the systems, right? These two are, everything is interrelated. When we dealing inside the system, it is called operating system. When we dealing the communication between two operating systems, that is called computer networks. Every subject is interrelated only. Anyways, second point, processing delay. So now the packet will be taken from the processing, which is called processing delay. Because if a processor is free, then the packet is moving from queue to processor space. Then this packet is taken up by this packet 1 is taken up by the processor and start executing one by one. That is, open the packet and it contains header. That is, what is the source, what is the destination, and it contains a trailer part. By applying some checksum, error correction detection method like Hamming code or CRC, and calculate it, and calculating and comparing all these things whether the data is correct or not. So for all these things, we need that processor takes some time. That time is called processing delay. Right? See, the time taken to process the data packet by the processor, that is the time required for intermediate routers to decide where to forward the packet up to update TTL. TTL means time to live means every packet, if it is not reached in a particular timer, then sender again send it. Best example, do you hear me?
Yes, sir.
So I'm waiting for 5 seconds. For my question is, do you hear me? 1, 2, 3,
Yes.
4, 5. So nobody is responding to me. No destination responding to me. I'm again asking the question. Do you hear me? 1,
Yes, sir.
Yes, sir.
2. See, within 2 seconds you have responded. So I'm happy. Again, I start with my class. That is called time to live. For every packet, there is a timer. By the timer, sender needs an acknowledgement from the receiver. Do you receive my packet or not? I'm waiting. Do you receive my packet or not? I'm waiting.
Yes, sir.
Yes. Yes means yeah, okay. Then I go for the next topic or next packet. That is called time to live. Perform header checksum. Header checksum means error correction detection methods, parity checking, many combinations. Anyways, we will discuss everything in coming units, coming modules. So it also does not have any formula since it depends upon the speed of the processor. The speed is completely dependent upon operating system services and hardware devices. And it is a different concept. It is completely related to a computer. It is not at all related to computer networks. It is out of scope for the subject. That's why we said that there is no formula for calculating. Because we don't know in worldwide, best example, we are all connected to, we 60 members connected to Zoom link, whether all are using same computer, same processor, same mobile phone. Is it possible? All are
No,
using
sir.
same Windows 10 only now?
No, sir.
No. So if it is not possible, how can I estimate what is your device? What is your mobile phone? What is the capacity of the mobile phone? Some people may be using 4G phones. Some people may be using 5G phones. Some people using some high-end processors. Some people may be using low-end processors. We can't estimate those things. So it is completely dependent upon the speed of the processor. Now, important points. As of now, we discussed about 4 points, 4 delays: transmission delay, propagation delay, queuing delay, and processor delay. In practical points or practical problems of computer networks, we consider first two only: propagation delay and transmission delay only. These two are negligible until and unless if they mention. What is point 1? What is total delay? Total delay means the time required to place packet inside the network, the time required to transmit that packet from one end to another device, the time required to waiting time of B, the time required to processing of the packet by B. This is called total: transmission delay, propagation delay, queuing delay, and processing delay. In real-time situations and problems, we are negligible. We doesn't consider these things. Next. Note 2. In optical fiber, the transmission speed of data packet is 2.1 into 10 power 8 milliseconds. Why 2.1 into 10 power 8? I said the 3 into 10 power 8, right? Why 2.1? Because optical fiber, light is the transmission medium. So if light is the transmission medium, then it is equal to light speed 3 into 10 power 8 milliseconds. Why 2.1? So my simple question is it possible to use the 100% of that light speed in optical fibers?
So because of internal reflection, maybe it'll
Yeah.
lose its energy.
Internal affections, coupling effect, or heating effect, many combination external factors are there. So in practical problems, we use only 70%. 70% of light speeds. So 70% means 0.7 into 3 into 10 power 8. So what is the value here? 2.1 into 10 power 8. This one. Most of the situations we are using, this is the best case. Only 70% of the, so in optical fiber, signals travels with around 70% speed of light only. It doesn't utilize all the 100%. That's why we got 2.1 and 10 power 8 milliseconds. Do you understand this?
Yes.
Right. So in general, if transmission medium is optical fiber, it is constant. If your problem mentioned with, if you're utilizing 100%, if mentioned only, then we go with 3 into 10 power 8. If you're not mentioning anything, go with this one. Now, both queuing delay and processing delay are depend upon the state of the system, state of the operating system and processor, of course. So this is because the destination host is busy doing some heavy processing, as I shown you by using task manager, then these delays will increase. If the destination host is free, no service is there, then the delay is less. It just depends completely. A note for any particular transmission link, bandwidth and transmission speed are always constant. See, some student asking me, if it is optical fiber, it is constant. If it is coaxial cable, that capacity is also constant. If it is twisted pair, that capacity is also constant. This is because they are properties of transmission medium, of course. Bandwidth is always expressed in powers of 10 and data is always expressed in powers of 2. As I explained the same thing, take a look of it. See, 1 kilobyte means 2 power 10, not 10 power 10. 1 kilobits 2 power 10, but 1 kilobytes per second, this is bandwidth 10 cube. 1 kilobits per second, 10 cube. 1 megabits, 10 power 6. Here megabits 2 power 20. So please be cautious about data binary data and transmission capacity, both are not same. So everything is good as of now. Any doubts? As of now, any doubts?
No doubts.
No doubt, right? Then I request all the students, please take a snapshot of this one. I request all the students, please take a snapshot of this slide. Do it fast. You need to solve these problems. I request all the students, please take a snapshot. Otherwise, open your Moodle box. I request all the students, open your Moodle box. See, are you able to see my screen?
Yes, sir.
See, assignment on network delays. Open that one. So we have 5 days of time. So it is delay problem. Whatever the things I show here, same thing is represented there also. So I request all the students, open this PPT, delays, understand the problem. And the problem is this one. You need to answer all these questions. What is the transmission delay in link 1? This is link 1. For time being, I'll explain one problem for you. I'll explain one problem, how to solve that one. So here link 1 capacity is 2000 Mbps, link length is 5 kilometers. So for example, I want to calculate transmission delay. What is the formula for transmission delay? Length of the packet by
Bandwidth.
bandwidth. Bandwidth of the channel. What is length of the packet here?
5 kilometers.
15,000 bits by what is bandwidth? Yeah, what is the bandwidth?
2000 and yes.
2000. 2000 into M means transmission rate, Mbps, whether we are calculating powers of 10 or powers of 2.
Powers of 2, sir.
Mbps, capacity, not data. Bits per second, capacity. See here, again, I'm showing this point. See here, bits per second, powers of 10. See bandwidth, bandwidth powers of 10, but data powers of 2. Don't confuse. 2000 into 10 power 6. This is the answer. For example, propagation delay, TP, length of the link by speed of light, speed of the transmission medium. What is length of link here? 5 kilometers. Yes, sir. 5 into kilometers means 10 cube by what is propagation delay? Here I am using speed of light propagation delay. That is 3 into 10 power 8. So how much it is? 5 by 3 into 10 power minus 5. Right? And what is the total delay? What is the total delay to reach from device 1 to router? It is TT plus TP plus TQ plus TPD. These two are negligible. So we can calculate this one plus this one. That is the total delay. In the same way, calculate these two. In the same way, they calculate these two. And total delay is combination of this 4 of this one, this 4 of this one, this 4 of this one. That is the answer. Any doubts?
No.
Any doubts? Yeah. So all of you open that Moodle box and download that PPT. Otherwise, you can take, here I am giving two problems. This is problem 1 Take a snapshot of this one. Otherwise, you can open that Moodle box also. That assignment is available there. Take pen and paper. On paper, right side top, you mention your roll number and name and section. Then draw this diagram neatly because we have 5 days of time. It doesn't take 30 minutes more than 30 minutes. Within 30 minutes, you can solve everything. So draw this diagram on that paper and solve question number 1, question number 2, question number 3, up to 10 questions, and scan the document and upload it there. Upload it, Moodle box assignment. Right? So this is problem 1, and this is problem 2. Questions are same 10 questions only. If you observe problem 1, here 2000 Mbps, 5 kilometers. If you observe problem 2, it is 1000 Mbps, 3 kilometers. Same type only. Right? I request all the students solve this problem by next week and submit your assignments. Meanwhile, so I need attendance. Here we have 49 members. I need absentees. Can anybody send absentees for me? Saurit or Vincent?
Sir, I will let you know, sir.
Manivenkat.
Yes, sir.
Do one thing, Venkat. Prepare a Google Drive document. There, every day, please post the absentees list there. Okay?
Oh, okay, sir.
Yeah. Today, but send the absentees list because some people yesterday reached me that they are that particular attendee is not updating in GLAM. So if I'm taking manual attendance, if any problems, I will take care of that one. For your purpose, I'm doing this one. Some Jeshwant, are you there? Jeshwant. No. Anyways, yes, Venkat, you can send. I believe that you have my WhatsApp number, right?
Yes, sir.
Send the absentees list to that my WhatsApp number. I will take care of your attendance. So I believe that as of now, everything is good. You are good with delays and try to collect some data related to nodal delay also. Nodal delay. It is a combination of all these 4 points only. Maybe in final examination, they may be asking about calculate the nodal delay of a device. You need to calculate everything. Simple thing. A simple question contains, we need to look upon what is processing delay. We need to look upon what is transmission delay, queuing delay, processing delay, and everything. So, and throughput means, what is throughput? Number of bits are transmitted per second from one device to another device. If transmission link capacity is more, throughput is more or less. The number of bits transmitted per second is called throughput. Within second, how many maximum bits you can transmit it or how many maximum packets you can transmit it from one place to another place. If link capacity is more, throughput is more or not?
Yes, sir. More.
Of course, more. If link can handle 1000 Mbps per second, of course, throughput is also per second. We can transmit 1000 Mbps. We are processing 1000 Mbps. That is called throughput. Throughput means number of bits in physical layer, number of frames in data link layer, number of packets in network layer. In the 3 cases, within second, how many bits are processed? That is called bit rate. Within second, how many frames? So that is called frame rate. And within 1 second, how many packets are transmitted? That is called packet rate. So these 3 things are common to throughput only, right? So thank you very much. And if you have any doubts, you can post in WhatsApp chat box. We are available there only. And I request all the students, please go through Moodle box and open that assignments and complete it within 5 days, by next time, by next Monday. We have a sufficient time, very small problems. If you really understand whatever the concepts I discussed today, you can easily solve like this. Within 10 minutes, you can solve it. But prepare the document clearly and upload it. Thank you all.
Sir, there's a doubt, sir.
Yes.
Sir, regarding lab experiment 2, we need some more time to do the assignments, sir. Could you please extend it, sir?
So, do you need more time for lab assignments?
Yes, sir. We need more time for lab assignments. For experiment 2, sir.
That's not a problem. If you want to spend a good time, I'll extend the lab. I do one thing. I just go to Moodle and I extend time there. Can I give one week more time?
Yes, sir.
Okay, sure. I will extend it. Thank you.
Thank you, sir.
Yeah, right.
hello, sir.
Yes, Vishnu.
Sir, in the second experiment only we have errors because we cannot find the protocols. So in HTTP, I can say that the data is transferred. I can see the data which is
Okay.
means that it is insecure. Like that, I cannot find the
No problem, Vishnu.
Like that protocol.
It is completely your own set of mind. If it is even, for example, if you are got selected for a job and it is your job, for example, it is their job, how can we do that one? How can I satisfy our organization manager? In that way, you can think it. If you are good with how to HTTP, that's fine.
only HTTP is coming, sir, and remaining protocols testing is not coming.
No problem, no problem, no problem. Whatever the protocol that is displaying on the Wireshark, you people are working on that only.
Yes, sir. For that only is coming.
Okay, okay, Vishnu, go ahead, no problem. Okay. Thank
Yes,
you,
sir.
thank you.
Yes, sir.